the James Webb Telescope has done it again. A newly discovered galaxy, so old, so bright, so strange, is turning our understanding of the early universe upside down. Z14 is not only a record holder in terms of distance, but also another unique cosmic mystery. It has unusual chemistry and explosive luminosity. And it has something that should not be missing, a central black hole. Just as scientists were putting forward new theories about galaxy evolution, Z14 is turning everything upside down. And on top of that, this galaxy could finally be proof that we all live in a black hole. Just when astronomers were no longer expecting any more shocks or incredible discoveries, Z14 appeared. A tiny, incredibly bright galaxy dating from an era when the universe was barely 300 million years old. The galaxy was discovered by the James Webb Space Telescope, and scientists couldn't believe their eyes when the telescope displayed a redshift value of Z equals 14.44. But the real sensation of this discovery lies not only in its distance, but in what Z14 does not have. This galaxy apparently has no central black hole. There is no trace of a black monster object, even though these are found at the center of every active galaxy currently known. And that's not all. The galaxy shows unexpectedly rich nitrogen signatures, and that is an indication of multiple generations of stars within the galaxy. Z14 is small, which would fit with its young age, but inside the tiny galaxy appears old, star-rich, and unusually luminous, but without a black hole. These contradictions have once again caused chaos. Just as the scientific world was recovering from the initial shock of the JWST discoveries, this ancient-looking tiny galaxy is once again requiring new ways of thinking. It's incredible because this galaxy of all places is now supposed to provide us with the evidence that we are all living in a black hole. MOMZ14, the most impossible of impossible galaxies. One thing is clear, the galaxy is not normal. Even in our cosmic age, it would not be an ordinary galaxy, but a special case without a black hole at its center. Our scientists are far from knowing all the galaxies in the cosmos personally, but so far a black hole has been found at the center of every known and closely studied galaxy. That's probably the data from a few thousand galaxies. At the edge of the temporal universe, the JWST is now said to have found a galaxy without a black hole. How can this be? And what does it tell us? Normally a small galaxy shortly after the Big Bang and without a black hole would be a treat for all scientists who are tracking the evolution of galaxies. It is entirely conceivable that very young galaxies do not have black holes. And that would actually be an important clue for researchers as to how galaxies really form. However, there is a catch. Because although MOMZ14 is small, it's simply too rich in structure, gas, and stars to really be a galaxy baby. MOMZ14 seems like a cosmic oddball, the odd one out among the odd ones out, or the ultimate rebel among the already scientifically challenging galaxies discovered by the James Webb Space Telescope. Scientists now have to explain not only the age, the absence of a black hole and the structure, but also the chemical composition of the galaxy. A high proportion of nitrogen suggests that at least 2 to 3 generations of stars have already died within the galaxy. This in turn implies that this galaxy has already undergone several stages of development and by today's standards is at least several hundred million to several billion years old. The absence of a black hole adds the icing on the cake to this cosmic mystery. As these objects in the centers of galaxies are normally considered to be partly responsible for regulating the formation and evolution processes, the question remains, was this black hole simply overlooked, or is Z14 proof that there are other ways in which galaxies can evolve? The cosmic paradox, the early universe is too full. Let's take a journey into the world of particles. Imagine tiny particles whizzing through the young, hot cosmos. Then the action cools down and the particles slow down. They begin to develop molecules and gases such as hydrogen and helium are formed. Compression causes a redistribution of forces around the expanding cosmos, which continues to compress the gas clouds until the first stars, consisting almost entirely of gas, form at their centers. The first stars soon burned out, blowing dust into the cosmos. The dust made the gas clouds even denser and more compact, causing them to spin even faster and form stars that were much more long-lived. This process continued until there were so many stars in the universe that they were drawn together by gravitational centers to form star clusters, which then formed galaxies. Everything in our researchers' plans was exactly right. The structure of the universe from the Big Bang to our present day on our blue planet had been reconstructed almost perfectly. Time, gases, mechanisms, developments, and connections. Everything fit until the JWST came along. Since then, an early cosmos has emerged that is too full, too starry, too bright, and simply too crazy. Galaxies like C14 are so numerous, bright, and chemically diverse, or weird that our researchers are running out of theories. It almost seems as if the universe wants to blow up our collection of formulas at this point and show scientists the way forward. But where is that? In the JWST images, the rebels of astrophysics are harmless-looking little red dots. No one would guess that these are scientific nightmares. The galaxies certainly didn't care. As compact, highly active galaxies, they were scattered throughout the young universe as a matter of course, and certainly didn't worry about whether scientists on planet Earth would be left breathless when they saw them 13 billion years later. Are we living in a black hole? The theory that turns everything upside down. What could this galaxy have to do with the possibility that we are living in a black hole? This idea that our universe could have originated inside a black hole comes from physicist Nikodem Pawlowski among others. He argues that so-called baby universes could be created by the collapse of matter in black holes, including our own. The theory also fits in with the chaos that researchers have now discovered in the early universe. In its early stages, the theory of life in a black hole goes back to the Schwartz cosmology of the early 20th century. Among other things, the German researcher came up with the idea that black holes are not necessarily just endpoints, but also origins, portals to new spacetimes, or even places where universes within the multiverse are created. So what exactly does this have to do with Z14? Well, if the universe originated inside a black hole, the early phases of our cosmos could have been much denser, hotter, and more turbulent than previously assumed. This would explain why galaxies like Z14 were able to form so early and with such complexity, and why there is such a diversity of young galaxies. The absence of a central black hole in the galaxy itself could also mean that the laws of gravity were different in the early days than they are today. This is postulated, for example, by effects such as torsion in extended theories of gravity such as that of Einstein-Cartan. In this case, the center of a black hole may not be an infinite point but rather a big bounce, a kind of cosmic rebound. Our entire universe could have emerged from this embedded in a higher-level mother universe. The observed rotation of many galaxies in the same direction, an illogical trend, could also point to a higher-level rotating origin system, a kind of cosmic legacy from the mother universe in whose collapse our universe was created. These ideas are not yet mainstream. But they are clearly gaining ground because the old approaches are no longer sufficient to explain what our scientists are seeing. Simply correcting the age of the universe is also no longer enough, as this could not explain the chaos and the many peculiarities. The 5 craziest galaxies in the early cosmos. Let's take a look at 5 of the most unusual galaxies discovered so far in the young universe. These galaxies are truly exotic, leaving scientists perplexed and excited at the same time. 1. JWST Z13-0, the record holder. With a redshift of Z equals 13.2, this galaxy was the most distant known galaxy in the universe for a while. It's shown only about 300 million years after the Big Bang, making it a real dinosaur among the star islands. 2. GN-Z11. The Hubble veteran. Hubble discovered the galaxy GN-Z11 even before the JWST was launched. The unusually old galaxy was still considered a curiosity and possibly an observation error because its existence only 400 million years after the Big Bang did not really fit into the overall cosmic picture. 3. CIS E93316. The premature giant. This galaxy is not only old but also extremely massive. According to current data, it may have developed much faster than previous theories would allow. A galaxy of this extreme size at such an early stage is a mystery. 4. HD1, a Big Bang sprinter. With an above-average star formation rate and ultraviolet luminosity, HD1 is one of the most active galaxies in the early universe. It may even be home to the earliest known population 3 stars, the very first generation of stars. 5. Sears 93316, Schrodinger's galaxy. In the depths of the James Webb Survey, astronomers came across this galaxy, which exhibits two contradictory properties at the same time. It was initially classified as one of the oldest galaxies ever discovered with an extremely high redshift value of Z equals 16.7, which would mean that it existed only around 250 million years after the Big Bang. But that was precisely the problem. Sears 93316 is far too bright, far too massive, and too structured for its presumed age. Galaxies of this type should not even exist at this stage in the universe. It appeared too old for its age. Some researchers therefore considered it to be a kind of optical illusion, an object that appears to be a primordial galaxy, but is actually much closer and older. The data was checked and suddenly a redshift of only around Z equals 5 emerged. This would mean that this galaxy would also not fit the picture of that time. Since Sears 93316 apparently exists in two places and at two times simultaneously, scientists jokingly name it Schrodinger's galaxy after Schrodinger's famous cat, which could exist in multiple quantum states at the same time depending on who was observing it.